Okay, here is a video for the second half of our Unit 3 Topic 1 quiz. It's nice that we actually had a quiz review day. It is going to be on all trig graphs, sine, cosine, tangent, cosecant, secant, cotangent, drawing graphs, writing equations, all of it. So let's start with writing equations. For this graph, the amplitude is maximum minus minimum, which is here, divided by 2. So that's 1/2 and negative 1/2. I actually can see that that's centered. So the A is 1/2, which is the amplitude. I'm gonna do period first before I do B. So the period is a pattern. So maximum to maximum here is a length of pi. So B is 2 pi over the period, that's 2. C is gonna depend on what equation I choose to write, and the midline at D, the middle here is 0. You can look at page 54 in your packet. It tells you how to calculate A and D and B. It gives you nice calculation notes. So for the equation, we've got A. I'm gonna pick cosine since the graph starts at a maximum. And then B, there's no horizontal change if I choose cosine at a maximum, or since there's infinite equations, I could say cosine starts to the right, pi. I'm not gonna pick sine because sine, the pattern is middle to maximum. So that's this x value or this x value, and they're not labeled. And on a quiz, we're pressed for time. We gotta make sure we finish before the bell rings. So I'm not gonna bother to calculate those when cosine are much easier to do because I can see those values. If you wanna get really wild and crazy, you can reflect your cosine graph and look for where the minimum is. So that's to the right, pi over 2. Or you can look even further over here to the right, 3 pi over 2. You only have to write one equation on the quiz. We know that. We will look at everybody's answers. We'll look for the reflection. We'll look for the C value. We have to look at everybody's individually. Okay, for number 2, the minimum is down here at -3 and the max is at +3, which means the middle is at 0 with an amplitude of 3. The period, here's middle, back to middle, so the period is pi over 2. So B is 2 pi divided by pi over 2. When you have a complex fraction like this, we multiply by the reciprocal of the denominator. So that is 4 pi over pi, which is 4 for the B value. So y equals 3. I'm gonna choose sine because sine starts in the middle and goes up to the maximum. So there is no horizontal shift. Oh, and no midline change, so 3 sine 4x is my final answer. That's one of the answers. All right, lastly for 3 here, the minimum is at -4 and the maximum's at 2. So let me actually calculate A and D. A is max minus min divided by 2. That's 3. D is max plus min divided by 2. -1 right here. So that amplitude checks out. The distance from the midline to the max is 3, so that's good. Just a good sanity check. The period, so middle, back to middle. Underneath there, it does say pi. If you aren't sure, I could do a half a period, like just this hump would be half the period. So if half the period is pi over 2, that means a full period, I would multiply both sides by 2, is pi. So there's that. All right, so calculating everything else. Amplitude will be 3. Oh, I got that here. So then B is 2 pi over pi, which is 2. And since it starts in the middle and goes to a maximum, I'm going to choose sine. Just for review purposes, I'll go choose this value for sine as well, so you can see what that would look like to the right pi. Don't forget y equals when you're writing an equation. You need a y equals. Okay, that is those equations. Graph. Label all the critical values. Okay, so let me put my quadrantal angles, which is if you think of the unit circle, 0, pi over 2, oops, sorry, you can't see that, 0, pi over 2, pi, 3 pi over 2, 2 pi, all the way around the unit circle. Sine has a max of 1 and a min of -1, and the pattern is middle, max, middle, min, middle. There is my sine graph. While I'm at it, let's do cosecant, because cosecant is the reciprocal of sine. So I'm going to put the same x values for all these graphs, actually. And if I imagine a very faint sine graph in here, anywhere there's an x-intercept for sine is a vertical asymptote for cosecant. And cosecant is built off the sine graph, so where there's mins and maxes, I can draw those curves going up and down. All right, let's do that for cosine and secant. Again, I'm gonna have the same critical x values. Might as well label both of them while I'm at it. 1 and -1. So cosine's pattern is maximum, middle, minimum, middle, maximum. And when you connect your points, you have to make it nice and curvy. No V shapes, no points. Especially for cosine, since we end at a max, you cannot imply that it keeps going up. It turns back around for the pattern. So again, I'm gonna faintly put my cosine over here for secant. Anywhere secant has an x-intercept, anywhere cosine had an x-intercept is a vertical asymptote for secant. Then the maximum and the minimum is where I'm gonna start to build my curves. So like I could go over here to negative pi over 2 if I wanna see that full curve there. Okay, tangent and cotangent, totally different than the first four. For tangent, I'm gonna think about my unit circle values, or you could just flat out memorize it. I like to say that I don't have enough brain space to memorize all these details. I like to refer back to what I already know. And I know that tangent from the unit circle is y divided by x for the y coordinates. So tangent is undefined up here and down here. So if I put my critical values on my graph, I'm gonna have an undefined or vertical asymptote at pi over 2 and 3 pi over 2. Now I remember if I go this way, that's negative pi over 2 just to get the full period in here, because tangent and cotangent have a period of pi, where all the other four have 2 pi as a period. So since tangent is y over x, 0 over 1 gives me 0 at 0, and 0 at pi, and 0 at pi over 2. That's not really enough to graph a picture. But I remember that tangent of pi over 4 is 1. That's one of our special values from the special triangles. So if this is pi over 4, I get a value of 1. Negative pi over 4 is going to be negative 1. So I get this S shape for the in-betweens. And then this is just that half. I could keep going over here. Now that I have tangent, I can do cotangent because it's the reciprocal of the tangent graph. So let me put my critical values. Anywhere that tangent has an x-intercept, cotangent will have a vertical asymptote. Cotangent of pi over 4 is still positive 1 because the reciprocal of 1 is still 1. So the curve in this case is going to go decreasing the other direction. Pi over 2 has a value of 0 because cotangent from the unit circle is x over y. So from here, x over y at pi over 2 is 0. At 3 pi over 2 will be 0. So this curve's going to go this way. And there's 2 periods for cotangent. All right, one more page. The graphs. 2 is A, so that's the amplitude. Amplitude is always positive, so you have to make sure, like for this one, it's gonna, A and amplitude will be a different value. B is the coefficient on X. Period is 2 pi over B, so 2 pi over 1. There's no C value, and D is down 3. So I always start with the midline. I like to draw a dashed line there because it helps my eyes know where to look. The amplitude is 2, so I'm going to go up 2 for the max and down 2 for the minimum. There is no period change or horizontal shift, so that is still then my nice unit circle values. Cosine starts at the maximum, goes to the middle, to the minimum, back to the middle, back to the max. Nice curvy shape. Okay. 6, amplitude, or A is -1, but the amplitude is just 1. The negative is a reflection. We'll get to that. B is the coefficient out here. It's 1, so the period is still 2 pi. C is left pi over 2, and there is no midline change. So negative pi over 2 is my starting value. Then I need to go a length of the period to over here. So I'm going to do negative pi over 2 plus the period to get my endpoint. If you are a calculator fan, what you can then do is do -1/2 plus 2 back to a fraction, and then put your pi back. So the endpoint is 3 pi over 2. Now I need the middle of that. So to find the middle, I'm going to add my endpoints up and then either divide by 2, or I like to say multiply by 1/2. If you're a calculator fan, you can do this in the calculator. I have a common denominator, so I'm just going to add it by hand. So that is pi over 2. If you want to use the calculator, so it's 0.5, well, I'll do -0.5 plus the 3 over 2. You don't need all those parentheses, sorry. Then divided by 2. So that's that 1/2. Oops, sorry, you can't see. That's that 1/2, but put the pi back in. Now, I could repeat this midpoint process for the middle of these points and the middle of these points. But what's nice is halfway between negative pi over 2 and pi over 2 is 0. This one's not as nice, so I'll repeat this process. So that's half of 4 pi over 2, which is pi. Okay, midline didn't change. Amplitude is 1. Sine starts in the middle, but now it's been reflected. So instead of middle maximum, it's gonna go middle, minimum, middle, maximum, middle. Last graph. A is -2, so the amplitude is 2. B is 1, so the period is still 2 pi. C is to the right pi over 4, and D is up 3. So let's start with that D. And then 2 up and 2 down. Right pi over 4. So then I need to go to my endpoint with the period. So to get the endpoint, I'm going to do pi over 4 plus 2 pi. If I get a common denominator, that's 9 pi over 4. For you calculator friends, 1/4 plus 2. There, oh, sheesh, sorry, you can see that. 1/4 plus 2, then back to a fraction is 9/4. Then I need the middle, so I'm going to do half of pi over 4 plus 9 pi over 4, which is half of 10 pi over 4. So 10 and 2 reduces, and this is 5 pi over 4. And then you have a choice for the other halves. You can look at the pattern and say, okay, since they are common denominators, what's halfway between 1 and 5 would be 3. So this is 3 pi over 4. And then see how it goes 1, 3, 5, 7, 9. So you can look for a pattern. If you're not a pattern person and you'd rather calculate, you can calculate this one, be half of 5 pi over 4 plus 9 pi over 4, which is half of 5 and 9 is 14 over 4. So the 2 and the 14 reduce to the 7. Same thing, you could calculate that one. So now for cosine, but negative reflected, instead of starting at the maximum here, it's gonna start at the minimum, go to the middle, to the, oops, too high, to the max, to the middle, to the min, nice curvy shape. You can print a blank copy from the notes posted in Drive and practice until you are confident for the quiz tomorrow.